So up to this point, we saw that HSRP, hot standby redundancy router protocol, you can say HSRP notion. HSRP provides us redundancy over till this point. Means if this router of mine fails, means the active router of mine fails, the passive will take over and he will become active. In HSRP, it's Cisco proprietary, and GLBP is also Cisco proprietary. HSRP can have only two routers, means one will be active, one will be standby. If you have others also, only one will be the one who will actively forward the data. Now, the scenario that we were discussing earlier, assuming that I have this kind of a setup, but if I say I have one more device, for example, if I say one more router or something, or let's take a PC over here. Let's assume that this is my web server, and somehow from the internet I am reaching to this web server, right? Now, if this is my actor, just assume that there is a server on the internet and we just are going till there. Just assume a scenario wherein we have a connection upstream, and that is why that is how I am reaching the website, google.com, for example. Now this PC here pings him. Let's do it in Paint. So this PC over here takes which path? This PC will take this path, because this is my active router, and if this link fails, it's okay. This will become the active, and he was standby earlier. He becomes active and he forwards the data upstream. But the thing that we want to test here is, what if this uplink fails? What if, and this router does not fail? See, this is active, this is standby. Standby will not take over this router until and unless he does not, this active guy does not stop sending hellos. So if you don't send hellos, active router, if you don't send hellos, then only I will become the active router, or else I will just listen to you, nothing much. But what if he is sending hellos, but his uplink goes down, the web connectivity, ISP goes down? In this, we can do something called tracking of what? Tracking of your uplink interface. What are we doing? We are keeping an eye on this uplink interface. There is something called service level agreements, SLA. Service level agreements, we will have some SLAs with our ISPs. We will keep on checking, we will keep on tracking the website or anything. Just assume that link, I am tracking this link state. If this link is up, means HSRP is good. If this link is down, then I will do something. What will I do? So now what are we going to do is, we will do uplink failure. Earlier we did this downlink failure, now we will detect. Now in this event, what happens is, I tell this router, if router, your uplink fails, kindly reduce your priority. By default, the priority is 100. I will say kindly reduce your priority by 10. Now, in HSRP, we saw a term called preemption. Preemption was disabled. What is this preemption? Preemption is what? See, for example, if this is the guy, this is the active router, he has the priority of 100, it's okay. He has the priority of 100, it's okay. But if I say preemption, this guy is 90 and he wants the election to happen. Preemption will forcefully have the election. It's like he will overthrow the lower priority. Now let us see. What if the preemption is enabled over here? I say router to preempt, enable preemption, and what will he check? He will continuously monitor the priority of the other guy. If the priority was 100 and I told router, if your uplink fails, kindly reduce your priority by 10, make it 90. What will this router do? He will see that his priority is 90, my priority is 100. He will pull the active state from him, and then he will forward the data upstream. Getting the concept? Let us see it once again. So if I say router 1, if your uplink fails, kindly reduce your priority by 10. If you reduce your priority by 10, he will see the priority is 90 on your side, and he will become the active. He will do the preemption function. Let us see how do you get it. So let us go ahead and do this. As of now, who is the active router? Let us check over here. See, he says I went to standby. Show standby. He is the standby router. What I will do is simply I'll just turn this link off so that he becomes packet tracer. Packet tracer crashed. Give me a moment. Okay, so we are back again. So now this router is the Hsrp. See, show standby. This guy is the standby router. So let me do that again. Let's go on this router's gigabit 0/0, G0/0, shut it down. Wait for a few seconds, just fast forward it. So this guy will become the active router. He is active now. Okay. Now I will turn it on. So now this guy was active. He went down, but he will not pull the state again. He will not become active back again. Now what we are supposed to do is we will enable preemption on router 2. So how do you enable preemption? Configure terminal interface G0/0 standby 1 preempt. Always understand this one thing, that all the commands are given inside the physical interface, so that is participating. And here, so I told him, if you see a lower priority, just pull off the active state from the other guy and you become the active router. Now here I will go on my gigabit 0/0 and tell him to keep an eye on the G0/1. What are we doing here? Configure terminal interface G0/1. Sorry, G0/0. I will say standby 1. I said track. So I tell the router standby 1 on the interface where all the commands are inside the G00. Standby 1 track interface track gigabit 0/1. And here you can specify decrement MENT by 10. So if you want, if the upstream router, if your upstream link goes down, what is the value that you will reduce from your priority? See, I tell him by default the priority is 100. Okay, no problem. So I will tell him decrement it by 10. See, so what am I creating? I am creating a service level agreement on this router. I am telling this router to, so I tell router 1, sorry, let's copy this one. So I tell my router 1 on the, keep an eye on gigabit 0/1. If this link goes down, reduce your priority by 10. And I tell router 2 to preempt. If you see a priority that is lower than yours, kindly pull the state from here to here and you will become the active router. So let us do that. If this routers, see, show standby will show me that I am the active router. My priority is 100. My priority is 100, default is this, and I am tracking the interface G0/1. I am tracking the state. If the state is up, this is fine. If the state goes down, I will reduce my priority by 10. And let us do that. Interface G0/1. I am turning off my upstream interface. I turned off my upstream interface. Let us see what happens over here. See, Hsrp state change from speak to standby to active. Why? Because I have preemption enabled. Show standby. It says I am the active router. Why? Because the other guy has a priority. See, standby router is let me check. Yeah, see, standby router is 1.1. His priority is 90. My priority is 100. So you told me if you see a lower priority, kindly take it off from him. The hello packets will tell him. So now the hellos are being sent properly. Hellos are being sent properly, just in case if the uplink fails and downlink is correct, this will reduce the priority. See, if I see earlier the priority was 100, but if I say show standby now, he will say, see, I have a priority of 90. Why? I did not play anything with the priority. I simply told him, if your uplink goes down, decrement by 10. And this is what he did. He saw that uplink is down. He changed his priority. See, default is 90. And I have reduced the priority to 90. That is the reason the other guy became active. Now you can play a lot with this. You can also play, you can also say your priority is 105. Let's do that in a moment. What I'll say is interface 0/0 standby 1 priority is 105 and standby 1 preempt. Sorry, standby 1 priority is 15 and standby 1 preempt. What did I do? What did I do here? I have a priority of 105 over here and a priority of 100 over here. And preemption is enabled on both sides. Preemption is okay over here and preemption is okay over here also. Okay. Enabled on both the sides. Now what I told this router that if your upstream link goes down, assuming that we have one more link to this one, what I'll do is I'll take another link. Yeah. So I told my router, if your upstream link goes down, kindly reduce your priority by 10, make it 95. If your upstream goes down, then this guy will become the active router, correct? So if his upstream link comes up, if my upstream link comes up, I will again set the priority to 105 and I will see your priority is 100. I will again start forwarding data from this path. So you can choose which way your data will go. So you can say like this. So if I want to do this, I can also do that, but simply it will add complications, nothing much. Just I already did this. So let us test it. So what I will do is, say here, show standby. It says my priority is actually 105, but my upstream link is down. That is why I have configured my priority as 95. And now preemption is enabled. What I will do is I will say interface G0/1 no shut. Once I turn on my uplink, see, I pull my state back. If you have seen the Hindi movie Prem Ratan Dhan Payo, that movie, one original Salman Khan and one duplicate Salman Khan is there, right? So the active guy is the original Salman Khan. He fails and the other duplicate guy comes into picture. Once he is ready out from the bed, he again says, I am the active router, I am the original king and I will be the one who rules. Simple analogy like that also is okay. So what are the commands we have seen till now? We have only seen standby 1 preempt, standby 1, you can say priority, and standby 1 preempt. We also said standby 1 track gigabit 0/1, and we can also specify that priority. If I say decrement 10, it can also do that. So these are the commands that we have seen today. This is for us to have a logical IP between them. This is standby 1 priority to change the priority, standby 1 to enable preemption, and standby 1 track to track the uplink interface. If my uplink goes down, reduce your priority by 10 and let the other guy become the active router. So let us see the basic difference. Hsrp is hot standby router protocol. VRRP is your virtual router redundancy protocol. See, Hsrp and VRRP are very similar when it comes to their behavior. Here you have an active standby. There is an a master and a slave kind of thing. GLVP is different. Hsrp and VRRP are same. Instead of standby 1, if you say standby 1, you will say the other command. But here GLBP is gateway load balancing protocol. In GLBP, you have two types of devices. Two types of devices means here one will be the AVG, and the other will be the AVF, active virtual gateway and active virtual forwarder. For example, if I say I have 3 routers in Hsrp and VRRP, we can have only one active and one standby, right? But in GLBP, these are my routers, one router, second router, and the third router. And there are n devices over here. Any number of PCs can be here. So in here we will choose one thing as the active virtual gateway, and rest all will be the active virtual forwarders. So HSRP, only the active router will forward the data, but in GLBP all these are forwarders. This guy is the one. See, for example, if a PC comes in here, he sends out an ARP request for the gateway. The gateway is 1.254. Who will give me the reply? Now there are three forwarders. So the gateway will give the reply to this guy for his physical address. Next time the PC2, he comes in for an ARP. For example, the second PC, he comes for an ARP. The ARP will be taken by the gateway, but the reply will be given by the of this interface. So second PC takes this path and goes out. If you have one more third PC on the network, and the third PC sends out an ARP request for the gateway, the request goes to the gateway, but the gateway will reply with the MAC address of this router. So this guy is taking this path. So if I say I have three routers and three PCs, the first PC goes this way, the second PC will go this way, and the third PC will go this way. So the difference between HSRP and GLBP is that HSRP only has one active and the others are standby. He is the only one that forwards. But in GLBP, you have all forwarding. Here the gateway is the one who will distribute the MAC addresses in a round robin fashion. Round robin means first I will give my MAC address as the gateway's MAC address. Second I will give his. Third I will give his. If I have the fourth PC, I will give him my MAC address. So implementing GLBP is again very straightforward. Instead of standby one, you will say GLBP1 and IP 192.168.1.25. It's pretty simple. All the preemption and all sorry, all the preemption and all are same in here, you can say.